So welcome. My name is Steve. You ready?
Yeah, they are.
Hurry up. You're going to miss it because you won't be concentrating. My name is Steve Swartz. I'm an architect on the Connected Systems division. I'm a box architect. We have, oddly enough, Don Box is not a box architect. We got architects that are doing long lead stuff, that are doing computer science. A box architect is the person down on the ground trying to actually get the next product out. And my job is to coordinate all the product units in our division, all 9 or 10 of them. Clemens, my colleague, my esteemed superior in all ways intellectual, is the program manager for the Connected Framework team, working about community relations with the WCF and WF and so on. And you are in the middle of 6 talks we're giving here, yesterday, today, and tomorrow. You're on the downward side of the hill.
Which doesn't talk about quality, of course.
Oh, no. It's just that every story has to have, growth and decline, and we're getting older. In the middle age, things are better than ever, but we know we're closer to the end.
That's right.
And the first talk was positioning all of our products. The last talk will be looking forward to what we're thinking about in the future. The middle 4 talks are all architecture talks. We already did the one on data. We already did the one on logic. You are here on the one on presentation. And tomorrow morning, we'll do the one on security. In all of these stories, what we're trying to do is first give you some idea about structure and patterns, and then talk some about how you think about those patterns in application, and then go through a bunch of scenarios. And this will be no different.
So this will be probably one of the few presentation talks at this conference, or they're currently hip, where you don't see a spinning video done in Avalon or some mashup done with Ajax.
Yes, because we're going to talk about presentation, but we're not actually the presentation guys. And so what we're thinking about is not so much how you put bits on the screen, but how you write the app that's dealing with the bits on the screen. Because you sort of think of the Connected Systems division that there's a screen over here or a device, and that's someone's business. And there's disks over here with lots of data, and how you get into SQL, that's someone else's business. And we're in the middle doing everything. And so the challenge for the stuff in the middle is, when you get to presentation, how do you deal with the information that's going to be determining what bits go on the screen or what bits go back out?
And how do the bits actually reach the user before we even talk about the screen?
There you go.
There you go.
So if I were to look at the kinds of presentation applications that are written today, they are of 2 types, generally speaking. There's a kind where I walk up to a screen and do some typing. And mostly what I'm about is generating information or behavior or messages that are going to then be sent out to some other part of my connected system. And later, I'm going to get information back as a result of that, which I'm going to display on the screen. But the initiator of any change in the world in that kind of application is sitting here using the app. And you might think of that as where the interaction part of the system is driving down through the data and logic to communication. Most all the standard client applications we know work that way, right? I'm using Word, I'm sitting here typing at Word, and mostly the job is to push data out to the disk. But the disk file hardly ever, unless I'm using an early beta version, spontaneously causes changes in my document that are reflected back up to the user. The second kind of user experience that we have today is kind of standard, is a gadget. Now, I had to go way back in history to find a time when it was 77 in my hometown.
Which is very hot.
It shows you how long ago. It's not that 77. It's the American 77. That's about 22 or 23.
I still wonder why you have this inferior scale.
Clemens, it's because it would be too expensive for us to upgrade. We try it every once in a while, but you don't want to ally yourself with the sort of a geeky American who is pushing for the metric system. It's an embarrassing group of people to be part of.
Yeah, because it's thoughtful.
Here's the corresponding. Why do you use that second-rate language? We got the one that's catching on. It's because we have no grammar, we got lots of words, you can string them together however you want, and everyone can understand.
Not everybody is intelligent to use another language.
People are more patient who use your language because they can find out the whole story with the verbs on the back of the paper.
Yeah, see, French and Italian and German and all the Scandinavian languages have elaborate rules, and you just can't deal with elaborate rules.
And we don't need to, and that's the good thing. We got elaborate rules as to our Fahrenheits, too. See, it all
just
is about...
simplest.
Well, you can't play both sides of that fence.
No, I do.
You just did, you naughty thing. So the point back to the talk is, we got data in the communication side here flowing out of someplace far away in the world and up to my UI. So there's all sort of gadgets on the side of Vista that are displaying information. I can't go into that gadget and edit the weather, much as I'd like to. It's just a display of something outside. Now, the trick with connected applications is there's a new pattern that arises that involves both bidirectional flow. Outlook is a great example of that. Sometimes the world changes because I'm typing into Outlook, and sometimes the world changes because something far, far away happens that pushes changes back to me. A connected presentation module in an architecture has to start dealing with bidirectional flow. And what that means is your area of concern changes. In the old world, mostly what you cared about when you were building user presentation objects is either the interaction layer, where you were worried about programming in WinForms or in Avalon, or Web 2.0, or the communication layer, where you're worried about getting data in and out of your module. Whereas when you start dealing with bidirectional connected clients, the big change is that data and logic become a much more important part of the app. You have to deal with them as the main focus. I'm not just dealing now with a UI or a wire, but the application is doing things locally that depend critical on coordination. And so what we're going to do now is go through a set of patterns that describe different kind of user interface exchanges and look at how they reflect themselves in a world where data and logic start to matter. In a simple pattern like a message editor, which is the old-time web experience, or the experience you get with Infopath, or most end-tier applications, you can think of the user experience as one where, broadly speaking, I'm editing messages in a congenial way, sending them off far away, and then displaying the message that comes back in an equally congenial way. There's not a lot of logic going on at all, so I don't need to run this in a very rich place. It makes perfect sense to run it inside a browser, for instance, or on a small machine. The thing about data is I don't have a lot of rich work with data. I'm just generating data, which can be in the presentation layer, and then pushing it out across the wire. So the message editor pattern is a useful one where most of the changes are happening in the UI, and the business is giving the experience to a person in the UI. The second kind of pattern, again focusing on the flow of data, is the data viewer. Here I'm watching stock information. I'm watching any kind of data being generated far away. And the job of this application is to present that data in whatever real-time or near real-time approximation you want so that it can be viewed. So the headlines in Times Square going by, that's an example of this data viewer pattern. And again, it's rather simple because all the data is flowing off the wire, and the job of the application is just to present it in a useful way. The thing you'll be thinking about when you're architecting these kind of applications is how to get the data into the smallest space, perhaps, or to make it easily accessible so you can look at it and in a glance get the information you need. But the point of these kind of applications is they're still rather straightforward. You're in the way of the little man. Now, a third and slightly richer kind of application is doing local analysis. And the difference between a local analysis and a messaging system is, in addition to the application needing to pull data from far away and display it, it will also store the data locally. And a big hunk of the application design, in addition to displaying things far away, is to actually look at the data you've uploaded. You're doing a lot of manipulations that can happen locally. You start needing more logic, more ability to process logic locally, so that instead of generating message sends with the clicks on the UI, you're now generating modifications to the logic you've uploaded. Of course, so what this is an augmentation of the interaction pattern of message editing with the addition that you're going to be holding data in a buffer. In order to implement these kind of things, you either need something like a Web 2.0 app, which starts letting you store data locally in a stand-aside safe cache in a temporary way, or you need a richer client that's in the more traditional sense that can upload data and store it on a disk or in the flash memory of your phone. But here we're saying that the next step up in these patterns in terms of complexity is doing a lot of local processing. Now, an aggregator is the opposite kind of problem to the local analysis problem. In the local analysis problem, we bring up one source of data and then starting to use logic to manipulate it. In an aggregator, we're dealing with many different data sources and providing a view of that data that's different than the one you can get in any particular place. Typical example of this is a mashup, where I bring data in from my map application and my dating application to show me the nearest possible dates that I can click onto if I'm looking for someone to go out with on the weekend. And so what happens here is that what you get is communication is mostly flowing up through a logic layer, where all the messages that arrive at the presentation are going directly through logic before they become data that's shown. You know, in a messaging system, you typically make a call and get back data, and it almost always gets displayed directly on the screen. You know, I put in a call and get back the result. Where here again, you need a fair amount of logic that either runs back on the server if I'm doing a mashup in a web app, or more commonly down on the client if I'm doing something like the New York Times newsreader, where I bring a bunch of news stories together and then display them in a smart way. But see what happens. In the simple patterns, I'm either going mostly up to the interaction or mostly down from the interaction. And then as I start with these more complex things where I'm doing data and logic, sometimes it's mostly the data being dealt with, and sometimes it's mostly a matter of logical aggregation. Now, a fully integrated, fully interactive, connected client has to deal richly with data coming in both ways. So let's think that through. I think of the user as a source of input, and the user is sitting there typing on the screen, looking at what's displayed, making changes in the system. At the same time, changes are happening out in the wide world, and they're reflected back up through an event notification system into the user's app. Applications like this, you want to start thinking of as services. They're just sitting on the service bus like any other module. Messages are flowing up to them the same way they would any middle-tier app. Because the goal of this kind of module is to be just like any other thing. A message comes up. Instead of the logic being in code or in a workflow, it's in the user. But architecturally, it's the same pattern. Now, what we know is the world is a much more complicated place when we move from one thread of changes to two. And so the challenge here for building these kind of things is that we start needing to deal with multi-threaded problems. Somebody can delete a record in my database at the same time as I'm trying to edit it. Things get more complicated when you have an application that's connected to a database through ADO.NET, connected to a message source through WCF, and got a WPF front end. And so what happens is you need an architecture where all of this data comes up through the logic layer, no matter whether it's a click or it's an incoming message. You have event handlers dealing with both of those changes, and their job of both of them is to go ahead and update the data. So rather than having the data owned by the UI the way it is in a message editing way, or owned by the wire the way it is in a presentation way where I'm pushing up, the data becomes a third entity in these architectures. The data is independent of the UI and the message. And the logic that's driven by the UI or the message has to respect the fact that it's not the only editor. And so the typical architecture you want to use here is to have both things get to modify the data, and then to have both modules subscribe for changes to that data and go ahead and do what they need to reflect the change to who they care about. So, message arrives from the wire, comes up to my logic. Logic looks at the current state of the system, decides everything's okay, modifies the data. The data is live, and so an event is fired. That event says, update yourself. The logic says, yeah, I recognize that message, I just saw it. But the UI says, oop, I'm going to have to change my display based on the fact that I have never dealt with that change before. UI gets clicked on. Decision made, everything's cool, I'm going to write that data down to the data store. Event is fired. Because of that event handler, the logic says, that button click, that change in the record, requires an update notice to go out. So from the outside, these kind of presentation modules start looking like pretty complicated services in your architecture. And from the inside, they look very much like an application hitting a little local database using an event system to react to changes.
So what's interesting, if you look at the internals and reason about the things that are happening when you write a Windows Presentation Foundation application, the core of a Windows Presentation Foundation application is not really about displaying anything. It's about handling data. You have a control, and a control is just an abstract set of properties that you can skin on. But really, the only thing you're doing is you are directing flow of data from one thing to the next. You have filters that can go and aggregate changes in two properties and cause them to be a change in another property. You can have a property changing, and you will run that through a translator, and that will cause a change in something else. So what you're doing with the Windows Presentation Foundation app, if you just think away the effects and the display, you're only thinking about how to react to events and cause that other data to be updated. That underlying set of so-called dependency properties that you're building with this, when you think about those things, when you reason about them, you can then wire up to things that happen in the user interface. The user interface, the actual experience that you have, is grounded in hooking up to events, hooking up to the data flows as it occurs per your design on the underlying classes in the Windows Presentation Foundation. So you can look at the Windows Presentation Foundation as being reflective in parts of what we're saying here.
Mm-hmm. And so what you end up doing, if you turn briefly from the architectural view to the implementation view, is you make sure that all the data that's shared between the changing agents has that kind of lively event firing strategy, either by using something like the data binding strategy in Avalon, or just by building a base class that stores data in an arbitrary way and fires events whenever the data changes. And then you can go ahead and build these architectures no matter whether you're using WinForms or Avalon, no matter whether you're using WCF or one of our early communication technologies, because you just have the ability to insert logic that can see any change and drive it out. But the internal architecture here involves separating logic from either messaging or presentation, and then coming up with a strategy of dealing with modifications. So what I like to do now when I'm thinking about presentation design for some of our technologies, because we obviously have a lot of that in our platform, and what I recommend to you is to start thinking about your applications this way. Because in addition to this architecture being useful in a simple case where you've got two connections, it turns out this architecture is also useful in a second really important part of a connected app when you're not there. When you've got on the plane in the proverbial sense and you're using your application in a disconnected mode. The naive strategy that people use for those applications is to say, oh, I'll just put everything in a queue. And those, I guess, are people who have never, in the middle of the night when they were sleepy on a plane, sent an email that they desperately wanted to unsend before they landed. In reality, connected apps don't just send out messages over and over in an unusual way. What they do is do rich modifications of local data and then periodically sync it. So when this app is disconnected with the architecture I just talked to you, what happens is the logic that's subscribed to the data no longer just sends messages out the wire, but rather keeps track of the send requests. Says, okay, I would have, if I was connected right now, send out this message. Oh, okay, I would have, if I was connected now, send out this message, and so on. So you keep a queue of change requests. If you're a crafty person, you can actually architect that queue in such a way that it can be optimized before you actually send the messages out to combine things or delete things or what have you. And then, depending on your application, you decide when you first link up, do I go ahead and send all those changes out, or do I first bring back the data that's happened since I've been connected, and then optimize again to see if those changes want to actually edit my change request before I send that out.
And of course, this all composes really well with the data story that we told you in the last session, because we were talking about ways how you can think about your data, think about caching strategies, think about replication strategies, and about all those things that you need to be considering. And only when you've made those considerations, you actually are enabled to do a true offline story, because then you know for sure which data you can bring up, which data you can actually bring up into a client, make that part of an offline story, and reason about how likely it is that you will succeed with your edits that you're going to make in the remote system that you're currently disconnected from. If you have in your data story a clear notion of when data will expire, when data will become risky to work with, if you embed that into your data strategy, then you can easily replicate that up into caches, and you can be disconnected if you know that the data you're looking at will only expire in tomorrow at 12. You are perfectly fine dealing with that in an offline situation.
So the funny thing is, in my situation, when I deal with customers and they're asking for architectural help, they want me to tell them exactly what they should do. The moment I begin telling them what they should do, they argue with me. And so this happened to us when we gave guidance about our technologies. People would say, when should I use .NET remoting? When should I use ASMX? And so in 2003, we said, use ASMX when you're talking from far away, use enterprise services when you need it, and never use .NET remoting in a distributed app. Keep it in app domain or in process. And ever since, people have argued with that. But that's the nature of these things.
Yeah.
So what I have to do is figure out a way of working through architectural conversations where I harness that stubborn and combative nature for the good of the person I'm talking to. And one of the things I found is people hate complexity. We all hate complexity, and we especially hate complexity when other people are telling us we got to do it. So a good way of designing a presentation module is to start with this picture and then erase all the lines you can. So you say, okay, these days what we think is that a presentation module looks like this. And then someone will go, oh, I don't need to, oh, good, we'll erase that one. And pretty soon you can work your way back to the more minimal strategy you need for your app. But the thing is this is a good baseline, because where we're going in an increasingly connected and sometimes disconnected world is your customers want more and more clients like this. They want clients that are richly connected. When you're doing people-ready process, you need a client that can be a part of an application rather than the driver of it. When you're on a plane, you want to keep working. When you're going on the bus on the way home. And so this pattern is really, really important. Now with presentation, it turns out that once you get this basic pattern in place, there are a number of things that come up. And I wasn't able to figure out how to put them directly into the patterns, but they're big, broad areas of concern that a lot of people are thinking about. And I wanted to share them with you and tell you our ideas about them. And then maybe afterwards we can talk if you have different ones. The first issue is form factor. Clemens wishes more than almost anything in the world that he could have that monitor up there on the top.
So the company which makes this respective display, unfortunately, is now going bankrupt for the second time, because their stuff is so high-end that nobody can afford it. But they have just the coolest possible hardware. So they're stitching together those 5 screens, and they're all 30-inch. So it's a complete monster. This is you need to buy a new office for this. Right? This is just huge, but so it's fantastic.
This is the sort of business that attracts venture capital better than customers.
Yeah, it already attracted 2 venture capitalists, and they both went broke on it.
But someone else will go.
So now their website says up for sale for the 3rd time. It's just it's astonishing. And then we have those little.
I wanted to put Dick Tracy's watch on there because that was a nice 2-way connected watch. But we have this one-way connected watch here that's downloading MSN information and displaying it on the wrist. Now, one of the great dreams of architects and some product planners is that somehow I can abstract the details of my presentation mechanism from my application architecture and have a module that is doing my app architecture and then somehow is generating events for the actual screen. So the question is, where do you make the swap between the form factor specific stuff and the form factor general stuff? My experience so far watching people is that in almost all cases, the dream of generalizing the UI logic is bad for you. It's very unlikely to me that an application that deals with the user through a wristwatch and the 300 pixels that are available there will be the right logical or user experience when I'm surrounded by 30-inch monitors. And so it's not just that I've got to figure out a different amount of data to display, but the whole user experience, the kind of clicks I want to have, the kind of options I want to have, is going to be vastly different. You know, my restaurant display on my wristwatch probably wants to set up one restaurant at a time with the click, click, click going through it. Whereas that screen up there can show me every restaurant in the Western United States.
And all tables on them.
And I can do big circles and do searches and have just a beautiful experience.
But so if you consider a screen like this, it's not completely ludicrous to just design an app that runs on that sort of hardware. Because if you think about an operations center where you need to keep a huge application in check, and you want to have a dashboard with all moving pieces displaying, you want to see them red when they blow up, well, you need to have screens of that size, which sort of give you that overview. If you have a control center kind of app.
This monitor is a danger to your financial stability when this company is unowned, isn't it, Clemens?
Yeah, this thing I believe costs $22,000.
Let me give you an alternative investment you might consider.
Deal or no deal?
No, this is something that I've learned as I've seen the lights come down on you from the sky. You're developing a shiny spot here. You might want to invest in a hair treatment company, which you're going to make more profitable, and that company is not going to help you. Just a warning.
I love you, Steve.
Clemens, some of the sexiest men in the world are bald, and you will soon be one of them.
Thank you that you think of me as one of the sexiest men in the world.
I didn't say that. I just said some of the sexiest men in the world are bald.
Yeah, and you said soon I will be one of them, and I
bald
appreciate
So the point is that it turns out we found that as you move from one form factor to another, you really want to change the relationship with logic and data directly before it in a substantial way. You don't want to be filtering events and then having that logic be the same. And so we've generally found when you think of form factor that the right thing is to have logic and data in that architecture presentation appropriate for the specific form factor, the kind of UI you can do, the kind of mouse or pointer object you have, the amount of bits you have on the screen. You want to take that into account when you're going ahead and building your UI. You also need to take into account the connectivity issues you have in a form factor. You know, when I first got my new phone and could run Internet Explorer on it, I was very excited until the 10th time that I downloaded 500 kilobytes of data and a bunch of Java apps when all I wanted to do was see a high school football score. And what you find out is that different form factors have radically different needs. Different kinds of bandwidth have radically different implications. It may be that we want reach in some situations, and that dominates our desire to do specific things, but it may not be right on my phone. So there's a whole raft, a whole different set of issues that are appropriate to think with each form factor. And that's got to influence your presentation architecture.
So if I want to search a wonderful restaurant in Seattle, let's just foreshadow one of the examples that we're going to have. I'd rather have a somewhat outdated version on my PDA that I can search locally, rather than to have the completely accurate thing on the web. Because if I update the restaurant search every time, as you know, if I'm roaming, you know, on a phone with GPRS, every single bit is plated in gold by value. And I just don't want to do that. I just don't want to download all those bits ever and ever again. So I'm happy if, you know, I have somewhat stale data, but I can operate on the local store. Well, you certainly don't want to have that on the web. If you're permanently connected, you want to have the fresh stuff.
So on my phone, for instance, when I bought this new phone, they had an offer to sell me about a dozen smart clients whose job it was to use the web services far away in a more economical way and do restaurant search and map and so on across their bandwidth, but to be much more efficient about it. So there's a funny thing.
And that's what MSN Mobile actually does.
Web 2.0 is winning the world and making the applications richer and richer that I can run when I have high bandwidth. And the smart client is making a resurgence on cell phones. And this is what I talk about. You can't assume that the architecture of your presentation tier is going to survive across form factor. And this, to me, is the scariest slide. And I think it's because when Clemens was growing up, everyone in Germany is well behaved. Whereas when I was growing up, the police were not my friends. And when I was driving around, I was always made nervous by them. And so even to this day, seeing someone in a blue hat look over my shoulder.
But it's a lady.
It doesn't matter. They're all police. It's the same sort of situation.
Okay.
It's authority figures, even bosses looking over my shoulder. That's why I always set up my office with my back to the far wall. So no one can be... So you just played into several childhood fears with this slide, Clemens.
Oh, did I?
Yeah, that's all right, though. I still love you just
But
as
you have a
much.
wonderful window office with a big window, so how do you deal with the
I
situation?
have my back to the window, so there's no one staring. And I put the blinds down. And I have my blankie,
So
and my
you could-
stuffed tiger. Scary, Clemens.
You could as easily then have an inside office and let me have the window office.
Next time we'll think about that.
Okay.
So anyway, the second big thing that ends up really mattering in a presentation application more than most is the issue of identity. The point is that most of the other parts of a distributed application are running in a relatively safe place. Your database and your middle tier applications are usually running either on your machines in the back office or on the machines at the desk of your employees or customers, machines that can be trusted. Whereas UI applications are running in public places, on laptops going around, they're at farther reach where your security infrastructure doesn't extend. And so the problem of identity becomes critical in a presentation architecture, even more so than it is in the back office. And here, there are talks that you can talk about, and we'll talk about security tomorrow. But the interesting architectural opportunity open to you by the card space technology is, in the past, you were pretty much stuck with usernames and passwords to establish identity, or the provisioning of credentials far away. And it was a relatively complicated thing to do, relatively expensive to pass those credentials around. You know, I can't think of the number of apps I've installed over the years where I then had to go to some web page and run an MSI to install the credentials to use it on my machine. Whereas now with card space, one of the things you architect when you're dealing with the thing is exactly what information is needed for this person to run this application. You know, lots of times, like one of my favorite websites to visit is a website called threadless.com. And threadless.com is a big t-shirt competition where hundreds of people around the world submit t-shirt designs. They print up every week the 3 or 4 competition winners, and then you go buy them. And nobody cares if some person comes in tomorrow and blogs as me. You know, the Threadless people don't care. It just makes a joke on the blog the day after. And as long as I've got a credit card number, which they don't store, they don't care who's buying shirts. And so their need to establish who I am is mostly just to correlate the history of my experience there. I maintain a sort of shadowy identity on the blog. My secret name is Steve Swartz, which astonishes the kids there because they've got names like Godzilla 3. And they're amazed. They say, what happens when you type your name into live search and what do you get back? And you know, they all find funny things. And I say, well, I have pictures of myself. And they go, wow, that's rad, man. But the point is that I'm over-identifying myself relative to the cultural norm of that application. And that's because there's not a very fine structure there. Well, card space lets me do that if that's what's necessary. They can go to the other extreme and only send my credit card to Threadless in an encrypted way that they can't understand, but the Visa people can. Or I could send them a credential that they could go to an authority and recognize that is, in fact, me.
So one profitable industry on the internet is keenly interested for legal reasons, whether you are, when you're consuming their content, whether you are over 18. However, all the people who are accessing those sites are keenly interested in not disclosing who they are. You can just imagine what that is. So with something like CardSpace, you can actually create a credential. You can have that actually vetted by a third party, which knows that what you're presenting as a fact is indeed a fact, that you are over 18. And you can choose if the sites would implement it that way, and we would certainly appreciate if they did. Go and, from a technology perspective, Steve, you're looking at me like this.
Well,
we certainly would, because that would be the claim story. That you can only, the thing you need to present really, that's what the interest is in, right? From a legal perspective speaking, is that one fact that you are older than 18 years old. And that's the only thing you need to tell them. That's the only piece of information you're willing to release. And if that's so, well, CardSpace would be enabling that.
So you're a marketer, Clemens, and now you've generated a headline out of our talk here that says Microsoft revolutionizes that industry with CardSpace technology. You are a spin master, Clemens.
Look, that industry.
Let's just move on, because I don't want to be tarred by your brush.
Okay. I keep saying, well, you know.
Never mind. The point being that the architectural thing to think about here is you can now be very crisp about the claims that are passing from your presentation layer to the rest of your application. And of course, you can do the same thing with the other non-UI modules in your system. We're going to talk more about that tomorrow. But the key thing is that influences heavily how you think about your presentation. A third thing here that we need to deal with when we're dealing with presentation is the fact that I can't always see the presentation module. It's really rare today to run databases or middle-tier logic in places where it can't see the rest of the app, except when we get into B2B systems. Whereas obviously a presentation module is constantly disappearing behind one sort of firewall or network connection or the other. Now, in a claims-based world, as this technology evolves, actually the need for firewalls goes away. It's kind of funny to be standing here 5 years after we were trumpeting firewalls and now talking about the architectural necessity to get over and beyond firewalls. But to give you an example, Microsoft's IT department is dedicated to completely removing the Microsoft firewall as soon as they can. Because once we implement a rich claims-based security infrastructure, we won't need a firewall. Every one of our resources will just be guarded by claims that can only be accessed when you have two-factor identification and then go to our STS to get the claims you deserve. So we believe a firewall just establishes something to attack. And instead, the claims-based architecture allows us to guard things. But in this world, we got firewalls. And they've become a nuisance. They don't let me share pictures with my dad. They don't let me get onto his machine to help fix his software problems. They don't let me run my work modules at home. I got to be VPNing in to do any sort of work. You know, they've got elaborate software to get me around the firewall. Well, the presentation layer is starting to see opportunities to use relay technologies and various tunneling technologies, the architecture of which is the presentation layer can make initial inquiries in a mutually visible sky place and then negotiate down to the most efficient way of transferring. And so one of the changes you're going to see in presentation technology over the years is, in not too much longer, we're going to be able to think about the fact that from the architectural point of view, every one of the modules in the system can see every other one. You know, we're getting to the place where we don't want to worry about things that aren't on the net anymore. And if you happen to be beyond a firewall, what's going to happen is the software is going to evolve so you don't have to think about it. And you can do that today with relays. There's several relays in the sky that you can use to build out your own application. And this technology will come along. So this is an issue that is going away in presentation architectures, and you need to start thinking about it now. Because if your architecture has a mobile or a laptop presentation service in its larger architecture, you're going to be finding that you are more and more able to take account of it richly as it moves around the world. The next big hunk of things with the presentation architecture is how it deals with the world where there's a whole variety of rich things that are all described by metadata. So here what happens in our picture is the client is walking up to the universe of available yellow things, and it has a particular desire on the metadata. What?
Eligible.
Eligible yellow things. And then, so in the metadata, each eligible yellow thing describes itself in the salient ways. And this allows our searcher to find the service that's right for her. Don't you go there. You were thinking about it. I know.
Of course I was.
So there you go. And so the point is that in a presentation module, if we want to achieve the equivalent of service-oriented loose coupling, it turns out that presentation applications are uniquely needing to be able to go out and query metadata and to have this discovery architecture. And so there's an opportunity as we move forward in these things to begin doing this query. You know, lots of times we have a lot of applications where when I get back to the corporation and I first connect, I then go into Active Directory and decide where I really need to be talking. And there's always a trade-off. We were talking about that. Microsoft has rented lines internally, and so is it better to go through all the lines in the world to Redmond and then talk to my disk? Or is it better to go from the least Microsoft lines in Europe and then up? Those are kind of questions that your application is going to have to start answering, as well as these more mundane questions of matching. And so the notion is that increasingly, whereas the bindings between relatively fixed middle tier and end tier things can be done through a service bus, the corresponding architectural idea here is searching through metadata, doing discovery, finding the right, wouldn't it be nice if when I was buying books, instead of having to go to a site, if I had a client that could look at all the bookstores, compare prices, and get me to the site to order it that today has the best price for my book? These are the kind of things that client applications are going to need to do. The final thing we need here is naming in our presentation layer. And here's the way to say, instead of having the metadata all presented and have me sort through, I need to be able to do the equivalent of an address on an ESB in the broad space. I need to be able to have, instead of a URI that hooks me to a particular website, I need to have a name which goes to an intermediary and finds the website that I then want to go to. 20-year-old idea in Corba, and a pretty rich idea in terms of DCOM and its administration worlds, but not something that we have today in the web. And so right now you're in a place where you need, as an application developer, to build this structure into yourself too, if you want to have a rich presentation layer. You need to have some naming service on the edge of your application or the edge of your enterprise, so that your presentation systems can be redirected to the right connection and you don't have direct coupling between them and the rest of your system. So metadata and naming are both ways, given current technologies, that you can achieve the equivalent decoupling you get with the service bus and your enterprise apps when you start thinking of the presentation modules as services. Now, Clemens entertained himself back before we were paying him by putting together a presentation where he thought about how applications worked back in the days when the messages were on paper and they were going from desk to desk in applications. And all the processing power was some guy in a 100-year-old suit, where it would be today. And so he had this whole presentation called Architecture of Apps in the 1920s. And it really is interesting how many of those architectural patterns came over. But we have a few slides to talk about other things, and since he is the author of these slides, we thought he would pass the baton early in the talk.
Thank you.
Clemens, I live to hear you say thank you, because you owe me.
I owe you everything that I know, Steve.
Oh, Clemens, you're so romantic.
Yes.
Uh-oh.
Oop.
We forgot to say turn off the cell phones, and that's what we deserve.
And promptly it happens. So there are two types. So if you look at the the way how applications interact with users. Today, very often applications just have a menu and users get to say what they want to do. However, if you look at very formal environments where you need to work through a business process, which is often the case, there are two types of tasks that need to be done to serve the process or to do something. There are tasks happening in the process that are very deterministic, which you can, if they happen often enough, encode in a workflow, which you can write a program for. The reason why we're writing programs in the end is to take something that is predictable and happens often enough and try to automate that task. So there's a lot of deterministic work that can be done. If it doesn't pay to do that deterministic work with a program because the program is too expensive to write, or it just doesn't happen often enough, we give it to someone who's probably doing that task manually. Very many sort of mundane tasks are outsourced, and Europe and America outsource them to India and to China, and that's a fact of life. There are tasks which are seemingly really easy and deterministic, but are really difficult to solve with a computer program, such as you get written letters or you get written forms, you get anything done in handwriting, just sent into you, and you need to put that into a program. OCR technology has come a long way, but there's just always a margin of error. So if you want to be really sure, you probably have to have a human looking at those papers and then punching them into a system. That's not a very highly qualified job, but it needs to be done by a human being. Then there are jobs which are entirely non-deterministic, means you can't predict the outcome in a system because some human needs to make a decision about those things. There are, for instance, let's look at banks. There are systems where you are scored based on who you are, and based on that you get a credit or you don't get a credit. That's okay if your business is, broad consumer loans. If you are in business, so you give business loans, you can't operate that way. You need to know the customers you're working with. You need to know whether they're creditworthy, even if they are in a financially stretched situation. There's a human factor in all those things. So in essence, there's two classes of tasks. There are tasks that are deterministic and they're non-deterministic. However, most of those tasks that you have in business, even in the sales process, even in processes which have to do with negotiation, etc., you have a process defined for them. So one of the goals of software architecture is actually put deterministic things and non-deterministic things in harmony with each other and just make them part of an architecture. We have business process, and that business process needs to be reflected in the system and then needs to be playing with all those other pieces. So implementing a process, if we think about things like BizTalk orchestration, or if we think about things like workflow, often we think about sending messages to a computer program. The computer program will deal with that message and then answer back into the workflow. Things will be correlated. And that's a very easy way to think about, because a program talks to a program, and that's what we really know. However, what if the task that we want to invoke is not deterministic? It's not something that can easily be solved by a program. What if that task that's part of the workflow, and it's just one element up in that workflow somewhere, happens to be non-deterministic? We still want to make that part of the workflow. We still want to engage that in the workflow. So how do we engage? Well, we happen to engage by sending a message to a message wizard, to a piece of software that acts as a message translator, which translates that task, translates that request, translates that inquiry for a decision or for a reason, for reasoning about the state of the workflow, for state of the business process, really. And lets a human answer that question, or lets a human contribute information to that, so that can be contributed back into the process and the process goes on. So instead of someone sitting there and going to a menu to menu to menu to menu to find their work. If they are bound to a business process, the work can find them. So what's the appropriate medium to deliver that work, to deliver the requests that the system has, that the entire organization has towards that individual or towards a group of individuals? Well, most of the knowledge workers today live in something like Outlook. So why doesn't the system take a message, take a SOAP message, if you will, determine that the execution of that task, and it does that through naming and directory and making decisions about those things, what's the module that's handling those things, goes out to a group, it has a visualization for that message, it sends a message to an email to an individual, and the individual will then be able to respond and feed that back into the process. It's not restricted to email. Often, if you just have a question to be answered, the process can go and connect to your user using something like Office Communicator or MSN Messenger and said, hello, I am the business process for so-and-so. I have a question for you. What do you think about this? Here's a link. Click that, and then please respond with yes or no. Is that a reasonable UI? Absolutely. In very many cases, it is. So it's not only applications are not, things that that have a window frame and that have a menu, but very often it's just like tiny little bits of UI, how you can get to the user, you can present them with information, you can feedback information to them. And this is people-ready process. This is when we say people-ready, and you see that on TV as ads for Microsoft. We're thinking about integrating users, integrating people into the process as a whole, and making it more normal to interact from the process perspective with people, and for people to be just collaborating with the things that are part of the software.
And so the interesting thing there is that instead of everything being a presentation tier at the beginning of your architecture, you're calling out to people in the middle tier. One of the application modules is a call to a user. I don't know if I would say that's just undeterministic things, because, for instance, I like to think of my annual review as a deterministic thing based on my hard work and great competence.
Yeah, you would wish.
I would like to think that. Nonetheless, if I was building a business process that contained that action, deciding on my review, and one of the things our team intends to do in the next release is actually build an application to manage our review process, there are going to be things that want to be called out to a user merely because it's the user's job. We used to think that automation was about making jobs go away. But in fact, there's plenty of automation that needs to be making your job structured. Imposing the business process, but having you do all the thinking. And that's a way where very deterministic things are nonetheless owned by the user, and you want to fit that into the app without having to artificially push all that back into the UI.
So it may be very well the case that the UI or the UI artifacts, and you can think of things like the Windows sidebar, you can think of things like Office Communicator or whatever IAM client you have, you can think of just having an email, will trigger an action, will bring up some sort of UI. Maybe may it be a web page, may it be a smart client application. But then you get the context of what you are supposed to work on. But then that smart client application turns around and turns to be a normal smart client app for many other things, because it may have to pull reference data. So it's kicked off by things that happen outside of the process. And it will present you a contextual message, and you will reply to that contextual message, and that's going to be fed back into the process. But the rest, it doesn't have to have the full context of everything. It may just pull in data from other sources as well, and then go and aggregate.
So in my end-tier application, the presentation layer may be a message arriving, and the business logic middle tier may have a UI. The difference between a presentation all the UI is a way of getting processing out of code and into a person. And it can happen anywhere in the architecture. And that's a big architectural change.
That's a huge change. So one of the things that for a call center that I've been involved in several years back was they were a call center for financial collections, like the guys everybody wants to speak to. and they were calling out, and they had 80,000, 100,000 accounts that they were after, and they were trying to get money from people. And of course, they would not reach anybody, so they were calling out. They have hardware that was just placing calls, and that hardware was able to listen in into the call the first second or so, and they would be able to determine whether someone answered that call, and then they would have to push the call, the connection, plus all the data to a terminal where a call center agent would be sitting. And in time that when the call was put through, they would see the name and then would say, hello, Mr. or Mrs. So-and-so. Hard real-time requirement, UI-driven exclusively by the hardware that sits out there and makes determination about whether someone is answering or not. The call center agent just sits there, hands off the keyboard, and the system just drives the data towards them. So let's look at a few connected scenarios. Let's step back and let's look at them. They're going to be fairly, so we go back to the patterns that we had, and we just put names on them. Restaurant search. Restaurant search may be purely, if you just look at the green arrows on the left side, maybe purely just a request and data viewer. The request just serves to go and give a few criteria, and so we're just pushing some information down. And then, or we may not be pushing any data down at all. If we look at the default start page of a restaurant search service, and it may know where we're coming from our IP address. We don't even send our cookie along. So it's a pure data viewer. However, the restaurant search that runs on the watch or that runs on a PDA will likely have a local store, will likely try to minimize the data that's being transferred just because of latency constraints, because of just the data volume, reducing the data volume. So that may do a lot of local analysis. Well, you don't want to do the local analysis on the web client. That may change, though, if you consider a mashup. So imagine we have this web page that we're making available as a restaurant search, and now someone consumes that page for meshing this up with local.life.com. But then you have two sources, you bring them all together, and you have a lot of rich logic working on the client to bring those two sources together. There's a lot of mashups of that sort, which do a lot of local analysis based on the raw, in quotes, raw data that they bring up from websites.
So this is a good example of why we separated out our discussion of patterns from our discussion of those considerations. Because here's an example where if someone just came up to you and said, how am I going to do a restaurant search application? The right architectural choice among the patterns is going to differ depending on what the form factor is. And so our patterns were to establish the base architecture, but all those considerations are going to be really critical in you deciding which particular way to go.
Infopath is very simple. Infopath is just a message editor. And in fact, it just surfaces in the clearest possible way because you have a form that you fill out. It has limited business logic. It's actually a little difficult to outfit Infopath with very, very rich logic. And so you just fill out a form. You have the capabilities in Infopath as you need them to validate that data. But in the end, you just want to conform to a certain schema and then push that down onto your middle tier, which is then going to reason about those things. So it's purely just a message editor. A sports score ticker is just pushing data at you. Now, you may be one, or a stock ticker in the same way. Now, Steve is very interested in his college team.
The Ohio State Buckeyes, #1 in the United States.
So you wish.
So they are, Clemens.
They are this year?
They are this year. They have been in recent years.
That
they do considerably better than that your football team.
Okay.
Neener.
Yeah, I can't say anything. I can't say anything against it. My team has sucked in the last few games. I mean,
few years.
No, well, you know. But that's love.
Is that what love is?
That's what love is.
I
Love
like
goes-
loving good, successful things, Clemens.
No, I think you go through losing times and through winning times with them.
Yeah.
It's love.
But you can gloat when you're going through the winning time.
That's true. So in a sports score sticker, you may just be happy with all the headlines and everything. So you'll just stream them up and they'll just display. You may also be tempted, and that depends on your scenario, to just run them through and do analysis on them, on the stickers, and just filter out information or just project them onto graphs or do all those sorts of things. But the data is just going to be streamed at you, and you make those decisions in the local client of how you want to display that data, how you want to filter that data, how do you want to deal with those particular things. The data stream will be the same because very often those things happen just in a broadcast fashion. These are the perspectives, the pivots of how you want to look at such data really depends on the personal perception. You will not get any other data stream from Reuters than, what's the New York Stock Exchange going to do today and what are the current prices. They're not filtering that down for you. But if you are just pivoting in on 5 or 3 stocks, well, that's what you want to do locally. Media Center downloads the EPG, the Electronic Program Guide. It would be not very wise if it went out for every time you want to look at the Electronic Program Guide and just download the whole thing again and again and again. Rather, it updates its program guide once per day. And then you do all the searches locally, and you want to filter it down. You want to see what movies are playing, what sports that's playing, and it's all local analysis that's being done locally. Outlook has, of course, multiple different forms of interaction happening. Email is a purely message editor, as it says. Email search goes against the local store, so that's purely local analysis thing. It goes against the data that you already have available. If you look at Outlook 2007, that has the search built in, it only operates on the mail that you already have in your local store. In junk mail, or if you have your inbox, the inbox actually goes into your data store and then first runs through a set of rules and junk mail filters before it actually gets surfaced to you. It lands in the store, but there will be decisions made about whether it wants to alert you or not. So stuff that automatically is sorted out by rules into different folders or sorted out by rules to go into the junk mail folders, you will not get a toast for. But only the stuff, you only get toasts for stuff that actually lands in your inbox. So that's pre-filtered. You will never see the raw data stream coming in, but you always will see a filtered, pre-processed stream coming in. Oops. There was an unexpected animation where that went away. So
a PowerPoint failure.
Sensational. So here we have 3 different angles of presentation that are all based in the same Outlook and Exchange pair of things. So it's Exchange presenting information to you. Exchange doesn't have the same presentation logic for all cases and all clients. Exchange 2007 now allows you to check your email from an ordinary phone booth because it's integrated speech technology. That, of course, is a completely different user experience and completely different reasoning behind it than presenting your email on a mobile phone, which is a smart client baked into the mobile OS. It's a completely different logic than Outlook Express, Outlook Web Access, thank you, that's actually delivered by the Exchange team as an AJAX experience. And Outlook, which is fabricated by or built by the Outlook team in Office. These are all different applications which serve the same purpose of looking at mail, but they're vastly different apps and have vastly different experiences. And it would be surprising if they were all employing the same logic, because sometimes the data is remote, sometimes the data is local. Sometimes you can look at all the data you have because you have a lot of bandwidth. Sometimes you only want to have a snapshot and just really want to scope it down what you want to look at. Sometimes the data is nowhere near local because you don't have a computer, you just have a phone to call in. Oops, that went one too far. There we have Messenger, and that starts playing all these different pivots that Steve was talking, or aspects that Steve was talking about. We have identity, we have naming, we have relay, we have directory. All these are services which have to be built, or had to be built, by the MSN team when they were building Messenger. There's an application which was built sort of as a proof of concept of whether we got all the factoring right for the frameworks, which is called Microsoft Max. And it turned out that that team that built Microsoft Max had to spend 70% of their time and code building those types of services. Because the idea here is that you have two applications sitting probably behind a firewall which want to talk to each other and also want to reach out to the world. So with Messenger, you can assume that people will sit behind a firewall. So you run into massive problems when you think about file transfer, when you think about calls, voice over IP, when you talk about video calls and all sorts of things, which require some sort of connection between the two parties, even though you can't connect to them. The thing that you can usually do through a firewall is connect out. What of course you can't do is connect in. So we need to have ways to get around those things. People roam around, and roaming around already means they get disconnected from the internet and they sit behind NAT and get reconnected with a different IP address. So we can't really know where they are. And they may appear on different systems. We need to have a way to discover them. We need to have a way of naming them. We are only interested to talk to Sabine, and Sabine is somewhere logged into Messenger, so I want to be able to find her irrespective of what IP address she's on. So first of all, I need to establish identity. For that, I need to have an identity service which sits there and can tell, first of all, that I'm allowed to use that service, but also guarantees my identity to others so that I'm not talking to the wrong person. The second is I need to have a way to register and identify my body list. And if I want to be able to find a way to find my friends on the net and talk to them directly, establish a connection to them. So for that, I need a naming service. For chatting and for sending files and doing all those things, I need to have a relay that goes and just brokers the messages between us because we can't do a peer-to-peer connection. And of course, if I want to make new friends, I need to have a way to look them up by interest and all those things, and that's what MSN does with Spaces today. And so I need to have a directory where I can look people up. And if I want to add a new contact to my list, there's got to be a way for the system to verify that that member is actually existing and add that to my naming service. The Microsoft Prime card is a thing that we all get as Microsoft employees as a discount card. So we can walk up to a store in Seattle and we get cheaper access to a museum, and that's a wonderful thing. So you can get the Museum of Flight, which I love, for like $3 instead of $12. And that's a wonderful thing. So those sorts of programs are interesting, very interesting to deal with in a software environment. We're going to talk about that in more detail when we talk about identity and access tomorrow. But the idea here is that I bring a card that's endorsed by a third party, in this case by Microsoft. Microsoft and the Museum of Flight have a relationship with each other, which says, you know, Museum of Flight gives Microsoft employees the right to go in for $3. And I prove this by presenting that card to them. The interesting thing is, how do I do this thing online? How can I present something that establishes a claim, the fact that I'm a Microsoft employee and in possession of a Prime card? How can I do and solve this possession of a certain claim? How can I broker that whole sort of idea? How do I do this securely in an online way? And these are things which are important for UIs. These are important for solving digitally things that we can easily solve in the real world. In the real world, I can go and present my card, and the card has a holograph on it, so it's safe from forging. And that's a solvable problem. But how do I solve those things in the real world? So that's also a concern for user interfaces. We're going to talk about that. So this is sort of foreshadowing for tomorrow morning. We're going to talk about that when we talk about identity and access in more detail. Now, my job is also very interesting in terms of workflow, in terms of how I interact with the system. We have an application called Bugger that interacts with Product Studio. Product Studio is our large bug database. It's actually not only one database, it's about 500 of them. But we have a common interface to them, and that's Product Studio. We have a little buddy application that goes with that. Someone wrote that, and it's actually very funny. So you run this, and it's looks like an IM client. But if someone assigns a bug to you, or if someone asks you to resolve or close a bug, it pops up a little toast that says, Steve has a present for you. I mean, quite literally, it has a little package. Steve has a present for you, and then you get notified that you have to do something. That's Product Studio's or Bugger's way of involving me into the process. It raises my attention to something that I would otherwise never see. Because Product Studio doesn't lend itself well to go and just browse the bug database, because there's a lot of stuff in that bug database. The bug database represents the life of the product as it is. So not only are there code defects, but there are just requests for you to write a spec or requests for any features. So you can easily accumulate hundreds of thousands of issues in one of those Product Studio databases. And so it's not a happy thing for you to just go browse. But you really want to react if someone assigns work to you, and you want to go and prioritize and do something about it and probably edit something in it. So the only reasonable way to interact with Product Studio is to use Bugger, to use that application which raises events to you, brings things to your attention, and then you can go and interact with the application and move it to the next state and probably assign it to someone else where they get alerted. So it's a completely event-driven architecture, if you will, Product Studio and Bugger together. But the actors in that whole environment are always human beings. And Bugger, that little application, is just driving the process forward. That's why it gets pre-installed, meanwhile, on the images that Microsoft IT pushes out to the whole environment inside of Redmond.
Clemens, we may be having a language problem here. Do you know the nationality of the author of the application Bugger?
Nope.
It's a British person. Does that help you understand the joke you seem to be missing in this discussion? Okay. You just weren't giggling the way you normally do when you're talking about something naughty. So the upshot here of what we wanted to have you carry away is there's a change coming in the way we think about presentation. Traditionally, we think of presentation as the beginning of an app, the thing that sits at the start of it and drives the rest of the app and the world that it happens. Whenever you have a UI, you typically draw that at the front of your application. Whereas what's going to happen is that the presentation modules in your architecture are going to start being just more services. They're going to plug into the rest of your application the way all your logic apps do. You're going to start reasoning about them and implementing them as two-way modules. They're going to start filling middle tier requirements as work needs to be given up to a user, a real person, in the middle of a business process. You have more options in this world than you think about. You have a huge array of technologies that you can use to build these things. You can build them with smart client technologies. You can build them with web client technologies. You can build them with mobile technologies. You can use prepackaged UIs like Outlook to register tasks in the middle of a workflow. So the trick is to understand this architectural change, to think about the particulars of your problem, and to make the right implementation decision for your presentation, forward-looking towards this way where your presentation and your logic start becoming more and more the same architecturally. We have we want you to go down, if you haven't gone down already, and participate in the Iron Architect competition. I think today's special event is the underwater dancing event in the swimming area, where architects are asked to see how beautiful a dance they can do before they drown. I believe that we still need you to fill out your forms, your review forms, and give us feedback. And we'll be down in the area later today, I think, after we're done with our interviews, and certainly tomorrow after the last talk, as well as Friday.
Absolutely.
Thank you very much for your time. We'll see you tomorrow.
Thank you.